I'm going to talk about performance of AI-generated magnetograms in EUHFORIA space weather forecasting model. Yeah. Background solar wind modeling is important as it influences the propagation of CME. So better modeling of background solar wind is needed for the accurate prediction of the CME arrival time. And to model the solar wind, we are using EUHFORIA, which is a 3D MH3 model. It basically takes the synoptic magnetogram as input to the coronal part, which simulates the plasma conditions at its inner boundary, which is 0.1 AU. And this plasma condition is fed as input to the heliosphere model, which then simulates the time-dependent evolution of the plasma parameters up to 2 AU. And the solar wind characteristics significantly change from Sun to Earth, but up to now, with EUHFORIA, we have modeled solar wind at 1 AU. But with PSP, we can do solar wind modeling at distances closer to the Sun. And while modeling solar wind for the PSP periods, so there are some instances where PSP was at the far side of the Sun. So we are using the default setup of EUHFORIA to model the solar wind during first 8 perihelions of PSP. And here we focus only on the modeling only the velocity and density of solar wind, as these are the main indicators which say whether a solar wind is fast or slow. And on the x-axis we have time, and on the y-axis on the top on the top panel we have velocity, and on the bottom panel we have density. And like we have marked the period where the difference between the PSP and model data are significantly large compared to the fluctuations in PSP, and we have color coded the underestimation or period where the underestimation of velocity is seen by red and the overestimation by green. And yeah, we see like there are periods of underestimation and overestimation in almost all perihelions. And I also would like to note that for the 7th perihelion, EUHFORIA did quite well modeling of the solar wind, and during this period, the PSP was almost on the front side of the Sun. So when we looked into the reasons for the discrepancy between PSP data and the modeled solar wind, we found three main reasons. One of that is the use of old magnetogram as input to the EUHFORIA. EUHFORIA used the old magnetogram, which had the size of the coronal hole before it rotated to the far side. So it either overestimated or underestimated depending the size on its old magnetogram. And the second reason was the behavior of the EUHFORIA at its inner boundary. Presently, we are not completely aware of how EUHFORIA behaves at its inner boundary. Sometimes it overestimates and sometimes it underestimates. And the third reason is when there is a coronal hole near to the polar coronal hole, the EUHFORIA tends to combine them both, and it overestimates the solar wind velocity. So here we have on the left the time series plots of the solar wind characteristics, and the trajectory of PSP on the right. And the PSP data is shown in black, and multiple EUHFORIA runs are shown in different colors. And this thick dash red curve shows the combined EUHFORIA data, which is produced by merging individual EUHFORIA runs by giving more weightage to the time when which corresponds to the center of the disk where the projection effect is low. And yeah, we tried to improve the modeling for the first 2 perihelions. And here we see like there are periods of underestimation and overestimation, and also periods when the PSP was on the far side. We are interested in these 2 perihelions with respect to the AI magnetograms because during later periods stereo was the AI magnetograms are used as stereo UV, so but the stereo was very closer to the Earth, so it could not see much of the far side of the Sun. So in total, euphoria, like during the 8 perihelions, while modeling it underestimated about 10% of time and it overestimated about 24% of time. And this is during first perihelion, and here we see the underestimation of velocity. And we try to improve its modeling by different ways, like we use different types, magnetogram from different times, and also we try to change the magnetogram from gong to gong adapt, which is shown in this thick blue lines. And also we back calculated the origin of solar wind from the source surface and used that magnetogram, the time of that magnetogram as input to euphoria. And those simulations are shown in thick red curves, but we see that none of the trials could improve the modeling. So to understand this, we backtrace the source region of our solar wind using a magnetic connectivity tool developed by ESA. And we see from this trajectory plot that PSP was at the far side, and this is the magnetic, the result from the magnetic connectivity tool. It points to this region from where possibly the solar wind of this period could have originated. It's dark because it's a far side, but when we look at the Carrington magnetogram at that region, we see that there is a small coronal hole. And when we see the trajectory plot, the PSP is around the east limb of the stereo A. So on the next days, it could come to the front side of the stereo. So we looked at those UV images. When we see that in UV images on next days, this is that coronal hole. We can see how it changes dynamically over a few days. But euphoria uses the old magnetogram, so it could not properly model the solar wind. So we wanted to try how AI magnetogram performs for this period. And also I would like to say, like when we look at the magnetogram, it's difficult to differentiate between quiet sun region and the coronal holes in magnetogram. So it's very difficult to detect the coronal holes in magnetogram, like when compared to the UV. So we expect to see a better modeling when the magnetograms are reconstructed from UV images. So to like the AI magnetograms, we are using the AI ones, which was recently published by Jeong et al. To generate the AI magnetograms, basically they are training the model using the SDO HMI and SDO UV images, and they use the Farside stereo UV images to produce the AI magnetogram for the Farside using the PIX2PIX-CC deep learning model. The daily magnetogram is available publicly, but the creation of the synoptic magnetogram is still on its preliminary stage, and we want to test this as input in euphoria. Yeah, as I told you earlier, during other perihelions, like stereo was much closer to Earth, so we are going to try only for the first and second perihelion. This is the same period where we saw, like, we tried different trials to improve the modeling, but we could not see any improvement, and we even tried AI for this period. But this is the dash purple line shows the simulation for that, like when we use the AI magnetogram as input to the euphoria. But we see it could not improve it could not improve because when we look at the trajectory plot, the PSPs are like the limb of the stereo or even behind, so it could not improve. So we wanted to check how it behaves in another interval. This is another period where, like, when the PSP was at the far side of the sun compared to the Earth, but at the front side of the stereo. And yeah, like when we look at the combined euphoria data, we see that it underestimates for this period, and also it could not reproduce the two peaks. Here we have the euphoria simulation when we use the AI magnetogram for this period, which is shown in a dash green lines, and also we have simulations using other magnetograms, like this blue curve is from when we use the Gong magnetograms, and these curves when you use the Gong adapt, like there are 12 realizations in Gong adapt, and we thought of trying 3, like to see how it differs, and like it produces different things. But when we compare, we see that like ASM has better reproduced at least the first peak, but later it hasn't reproduced properly. But this could be probably due to the synoptic maps are in its preliminary stage, but yeah. Yeah. Like also we wanted to check how the AI how the inner boundary magnetic field maps looks when we use different types of magnetograms as input to EUHFORIA. And the blue color shows the positive polarity and the red color shows the negative polarity. The darker the color, it denotes the open magnetic field regions. And this is from AI. This is when we use the AI magnetogram. This is GONG, and these are from the GONG adapt magnetograms. And when we look at this period, like this coronal hole is better reconstructed when we used AI, so it seems coronal holes are better reconstructed at inner boundary when we use the AI magnetograms. So the summary. When we look for the divergence of PSP data from solar wind modeling, we found that there were 3 reasons: the use of the old magnetogram and its behavior due to the behavior at inner boundary, and when there was a large coronal hole near the polar coronal hole, so EUHFORIA was usually overestimating. And yeah, we see that coronal holes are better reconstructed at inner boundary when we use the AI magnetograms, but still the simulations using AI magnetograms doesn't show significant improvement. This could be probably due to the pre-processing, pre-processing of synoptic AI is not still optimal, so we expect to see better results with the improved version of synoptic AI maps. All these results point to the importance of input magnetogram to EUHFORIA as seen by Hinterreiter et al. And our simulation during the 7th perihelion also supports this. So thank you for your attention and for this opportunity.
Thank you. Do we have any? Okay, we have one question in the back.
Hi, great talk, really interesting. I was just wondering, have you looked at or considered the fact that, a lot of studies have suggested that the source surface height that you use in the PFSS is not always 2.5, that's not the best solution, and that will really affect the back mapping, which might explain some of the differences.
Yeah, we have looked at for some intervals, it could really change when we change the source surface heights. Yeah, particularly like we had to lower the source surface height for the solar minimum periods. Yeah, we have seen that.
Thanks.
Do we have any more questions? Okay, one from the online audience.
Yes, very good talk.
Thank you.
One idea that come to my mind to kind of try to minimize the problem that you are using all magnetograms is whether you can introduce Farside acoustic maps, the ones that are made with the Dopplerograms on GONG. Yes, it's true that you cannot account for the coronal holes using those acoustic Farside maps, but you at least can account for where the active regions are located, and you'll get a higher probability of identifying regions of quiet zone that could potentially have coronal holes. So I wonder how difficult or easy you think that could be and beneficial to introduce those acoustic maps into your analysis.
Actually, we are thinking of doing that, but we haven't done that. But yeah, we are thinking. But it could. I think it should be simple to introduce those maps as input to EUHFORIA. Yeah.
Cool.
Thank you.
All right. Any more questions? Okay. Thank you very much.
Thank you.
Thank you.